Well, hello again, and welcome to the 15th episode of Simply Electronics Basics. In a previous episode, we've already looked at diodes, but we only looked at the principle of standard diodes. But there are different types of diodes that have different properties. We're going to take a look at Zener diodes and what makes them different from a standard diode. So, if you watched my previous diode video, you will know that the basic principle of diodes is that they allow current to flow in only one direction. If I were to reverse the direction of a diode, putting it into reverse bias mode, and connected a power supply across it, the diode would not allow any current to flow through the circuit. And that is exactly what this Zener diode is doing. When this diode is reverse biased, it is preventing any current from flowing through the circuit. In this sense, Zener diodes work exactly like a standard diode, with the exception of one thing. Zener diodes have a specified reverse breakdown voltage, also known as a Zener voltage. And what this means is, if you reverse bias a Zener diode, it will prevent current flowing in a circuit only up to a certain voltage. So this Zener diode is currently reverse biased and is preventing current flowing through the circuit. This Zener diode has a specific breakdown voltage of 10 volts, and I am currently supplying 5 volts to the circuit. So in this case, current is not flowing through the circuit. However, let's have a look what happens when I increase the voltage to the circuit above the Zener diode's breakdown voltage. And as you can see, as I move above 10 volts, current starts to flow through the circuit because the Zener diode's breakdown voltage has been exceeded. Now if you're thinking, well, what's the point of having a diode that can conduct in both directions? Well, a Zener diode can come in very useful for creating voltage references, shunt voltage regulators, and over-voltage protection circuits. So let's have a look at an awesome example of how a Zener diode can be useful in a circuit. Take a look at this circuit. I have a 12-volt power supply with a reverse biased Zener diode. Its reverse breakdown voltage is 10 volts. So therefore, the breakdown voltage has been exceeded by the 12-volt power supply, thus allowing the current to flow through the circuit. I have a voltmeter on the side here, and it's measuring 9.94 volts. Let's have a look at what happens when I increase the voltage of the power supply. Okay, so I've increased the voltage of this power supply to 51 volts. But look at the voltage across the Zener diode. It is still approximately 10 volts. So how exactly has that just happened? I'm supplying 51 volts to this circuit, exceeding the Zener diode's reverse breakdown voltage, yet the Zener diode still only has 10 volts across it. In effect, we have just created a 10 volt voltage regulator. If you want to find out how that worked, we will cover this in a later video, so make sure you subscribe to this channel, give the video a thumbs up if you liked it, and leave your comments below.